Write a program to exchange the lower nibble of the data present in the external memory 6000H and 6001H. Okay, now it is since the external memory. Okay, now this is 16,000. Obviously you have to store this address in DPTR. Now once DPTR, how do I access the address? It is MOVX instruction. You should be able to recall that. Okay, now whenever data has to be accessed, it is accumulator comes into picture, that you should remember. Okay, MOVX instructions only work with accumulator. Accumulator is the only one register which can access the data from there. Okay, now how do you write this? They have told only the lower nibble. Okay, the higher nibble has to be same, only lower nibble you are exchanging. So again, which instruction you are going to use? There are different types of exchange instruction. Since you are going to exchange only lower nibble, so for that exchange D instruction you'll be using. So this is the program. org 000H. Okay, your program starts from 00. Okay, now since it is the external memory, I told you DPTR, it is 16-bit this one register which holds this address 6000. Okay, now in this 8-bit data is there in 16,000. Listen properly. In 6,000 8-bit data that you are accessing in accumulator. Now since it is external memory, in the question they have told it is external memory, so you are going to use this instruction, MOVX instruction. When I use move instruction, it is understood that your accumulator is accessing the external memory which is pointed by DPTR. First 3 lines are clear for you?
Yes, ma'am.
Yes, ma'am.
Okay, now I have accessed the first value. Okay, now next move r0 comma hash 45. This is some random address you are taking. Okay, move r0 comma hash 45H, move at r0 comma a. So what happens here? 245. I am using here indirect addressing mode at r0. In this I am sending the value of accumulator. Now what is accumulator having the value? It is having 6000. In 6000, whatever the content it was there which was moved to accumulator, that is now shifted to r0. I hope this much is clear for you.
Yes, ma'am.
You want me to repeat?
No, ma'am.
Okay.
No, ma'am.
Now, in the question they have told 6,000 and 6,001. Now 6,000, since this address is stored in DPTR, DPTR can be divided into DPH and DPL. This is DPH and DPL. Okay, now I have told DPTR together it holds 16-bit. It can be split into two 8-bit, that is DPL and DPH. This is DPL and DPH. Now if I want to increment only lower nibble, what I can do? I can use DPL, increment DPL. That's what is done here in the question, increment DPL. When I use increment DPL, your 6,000 becomes 6,001. Together DPTR. Together DPTR address will become now 6001. Okay, now DPTR is having the address 6001. Here it was having the address 6000. In 6001, whatever 8-bit content is stored, that is pushed to accumulator now. Same way how we did now, how we accessed 8-bit here, same way we are accessing now the 6001 content, whatever there in 6001, that is pushed to accumulator. Now accumulator is having 6001 content and R0 is having 6000 content. The question here says I'm supposed to exchange between these two, but I'm not disturbing the higher nibble. I'm only exchanging the lower nibble. Yes, no? Since I'm exchanging the lower nibble, I'm supposed to use exchange D. This exchange D instruction, what does it do? It will only exchange the lower nibble. So A at R0. R0 is having 6000 content and A is having 6001 content. Only the lower nibble value is exchanged. Now exchange part is done. Now we have to store back the exchanged value. Now A is having that value which is pushed to DPTR, which is pointing out to 6001. Again, since the DPTR was decremented, which was pointing out to 6001, I'll again decrement to 6000. I'll only decrement DPL. It becomes now 6000. Again, the content of R0 is pushed to accumulator. This much is clear for you?
Yes, ma'am.